Hello students, welcome to video lesson 631B. In this video, we're going to talk about sort of our last formulas that we can use to rearrange or simplify trigonometric expressions. Okay, and in this video, we're going to be talking about half angle formulas for sine and cosine. Okay, so our goal at the end of this video is to arrive at a formula for the sine of some angle theta. In this video, we're going to use theta over 2. Okay, basically theta divided in half. So half of the angle that we were talking about originally, sine of theta divided by 2. And then we also want a formula for cosine of theta divided by 2. Okay, and this is the one we're actually going to start with, the cosine formula, the cosine half angle formula. So the cosine of theta divided by 2 is what we're eventually going to be finding a formula for. And this one comes directly from one of the double angle formulas that we looked at in our last video. Okay, so remember in our last video, the angle sum formulas led us to the double angle formulas, right? Cosine of 2a and sine of 2a. Now the double angle formulas are going to lead us directly to our half angle formulas, all right? So if we look at this double angle formula for cosine, the one that said cosine of 2a is equal to 2 cosine squared minus 1. What I'm going to do is I'm going to solve this equation for cosine squared. Okay, and then when I do that, by the way, it makes its own sort of potentially helpful formula or substitution that we can make at certain points. Your book specifically mentions that it's very helpful in calculus. Obviously, we are in pre-calculus, so it seems relevant to us. So what I'm going to try to do is solve for cosine squared by first adding 1 on both sides of the equation. And I'm going to make this left side say 1 plus cosine of 2a, if that's all right with you guys, as opposed to cosine of 2a plus 1. It means the same thing. Either way is totally fine. And then, of course, to solve for cosine squared, I also need to divide away the 2. So I'm going to do that all in one step. I hope we're okay with that algebra. Divide away the 2, and that shows up by dividing the entire other side by 2. And now this is equal to cosine squared of a. So what I've done is I've just gotten the cosine squared all by itself. So now, just so you know, anytime that you see the cosine squared of a, that is equal to 1 plus cosine of 2a all divided by 2. So again, another helpful, potentially, substitution to make cosine squared for this other stuff here. Now, remember that our goal in the end is to end up with something for cosine theta divided by 2. So what I'm going to do is I'm going to make a substitution here. Okay, I'm going to make a substitution that says 2a, I'm going to replace with theta. The reason I'm doing that is I want you guys to see sort of the relationship between what's in the parentheses for this cosine over here and what's in parentheses for this cosine here. Notice that this is just a, right? Angle a. And then this is 2 times a. So what's in parentheses for the cosine squared term is half as much as what's in parentheses for the cosine term. So if we replace this with theta, if we replace the cosine of 2a with the cosine of theta, then what should I replace this a with? Well, if I get a by itself here, cancel that out, a is then equal to theta over 2. So this right here becomes, so this is still plus 1, it's still divided by 2. So this is equal to cosine squared of, my a is now equal to this theta angle divided by 2. Okay, and so once I unsquare this piece now, I will have the formula that I'm looking for. So I square root this, and I then square root this whole side as well. Now, the last thing to remember in terms of this formula is when we square root, obviously, if it was something squared, then the squared just cancels out and the square root goes away, right? So the whole right side here is just going to be equal to, I'm going to deal with that one later, go away, go away. This here is just going to say cosine of theta over 2, just like I want it to. Okay, cosine of theta over 2. But this left side, this whole crazy square root business, we don't actually really know anything about what's underneath here. So when we square root this, it is important to give ourselves the option of a positive or negative version. 1 plus the cosine of the angle divided by 2. Okay, that is my half angle formula for cosine right here. So this all is equal to the cosine of theta over 2. All right. So once we have this formula derived, this formula is a lot more useful for finding the cosine of specific values that we don't normally see on our unit circle. Remember, that was sort of what our goal was with our angle sum and angle difference formulas in section 622, where we were finding specific exact answers for cosine and sine expressions that we couldn't find just from our unit circle. So for example, this would allow us to find, say, whoops, I gotta go back to my pen here. Say the cosine of 22.5 degrees, right? We can find an exact value for the cosine of 22.5 degrees. We can find an exact value for the cosine of 3 pi over 8. Okay, all kinds of new values that we can find exactly by using this formula. Okay, recognizing that 22.5 is just 45 degrees divided by 2, right? So we would put 45 over here, we would do this formula, right? And we would go from there. So we also want to be able to do this for sine. So if we look at a different double angle formula for cosine, this is going to allow us to use basically similar logic, similar steps to find the half angle formula for sine. So again, in the end, my goal is to have something sine theta over 2. I am going to keep in the back of my mind that eventually 2a is going to equal theta, and I'm going to make that substitution in a little bit. My first step here is to solve for the sine, trying to get that by itself, okay? So the first thing I'm going to do is I'm actually going to minus 1 over here. So it's going to be, I'm going to call it -1, right? So there's a -1, and then a positive cosine, so plus cosine of 2a. And then, of course, I also need to, well, here, I'm going to do this separately so that we can see what's happening here. Notice that when I minus the 1 and get that away, it doesn't take away this negative sign on the 2. So I'm going to have to do that when I divide by -2. So divide by -2. And that can actually flip the sign on both of the things on top of this fraction. So I can change it to +1 and change this to a minus cosine, and then change that to a +2, okay? So what I end up with when I cancel this out is this side says sine squared of a is equal to 1 minus cosine of 2a divided by 2. Okay, so the sine squared of a is equal to 1 minus the cosine of 2a divided by 2. And then, of course, I can square root this, and that'll get the sine all by itself. So now it just says sine of a. The other side is going to say, again, when I square root this side, I need to remember that I need to give myself the option of positive or negative. 1 minus cosine of 2a over 2. And now I just need to make my substitution. If you remember from before, 2a is going to be equal to theta, which means that a is going to be equal to theta over 2. So this becomes, sine of a becomes sine of theta over 2. And then this is going to be equal to, again, positive or negative square root of 1 minus the cosine of now theta, because I've replaced 2a with just theta, over 2. Okay, and this is my half angle formula for sine, this guy right here. Okay, so now again, this is helpful for us finding exact values based on our unit circle answers, but we can also do this not on the unit circle, but from a triangle. Okay, so I'm going to do one example, which is basically going to lead us into number 109, which is part of your homework. we just finished number 108 together with those two different expressions. And so now we'll just move on and look at one quick example of the application of these half-angle formulas. So let's say, for example, that we know that the sine, whoops, I gotta go back to my pen again. Let's say that we know that the sine of some angle x, the sine of x, we know that that is equal to, let's say, 5/13. Okay, we know it's equal to 5/13, and we know that x is somewhere between pi over 2 on the unit circle and pi in the unit circle. Okay, so the sign is positive. We are in the second quadrant. Okay, pi over 2 to pi would be second quadrant, right? It would be this side over here, pi over 2 to pi. And what we're going to have to find is we're going to try to find the, well, we're going to find a bunch of things. We're going to find the cosine of x, then we're going to find the sine of x over 2, then we're going to find the cosine of x over 2. All right? So we're going to start anytime we are given a sine or cosine value or a tangent or anything, in terms of a fraction, we're going to start by making ourselves a right triangle. Okay? So I'm going to make myself a right triangle, and I'm going to start labeling some of my sides. I know that, let's say this is my angle x, and the sine fraction, so katoa, is sine opposite over hypotenuse. So this must be 5 and this must be 13. I'm going to use the Pythagorean theorem then to find this other side so that I can write a cosine fraction for myself. X, well, x doesn't matter. 5, 13. Okay, so 5 squared plus question mark squared is equal to 13 squared. If we do the Pythagorean theorem, we find out that that's 12. Okay, so 25 plus question mark squared is equal to 169 minus the 25, and we get 144. Square rooted is 12. Okay, 5, 12, 13 is a Pythagorean triple. So now based on this triangle, we should be able to find the cosine of x. Okay, we should be able to find the cosine of x. The cosine of x is 12 over 13, except we have to remember that this x angle is in the second quadrant, right? It's between pi over 2 and pi. So in the second quadrant of our unit circle, over here in this part, are my cosine values, which remember are x coordinates. Cosine values here positive or negative. Well, we've gone this way in the unit circle, right, to the left. So the cosine value needs to be negative. So this is negative 12/13, which is going to be important when we go into our half angle formulas for the other two. Okay, so I've now found the sine and the cosine. The sine value is now no longer particularly relevant to me because both the sine and cosine half angle formulas are based on cosine of x. All right, so I don't really need this guy anymore. So I'm going to get rid of this. And I'm going to start thinking about what happens when I take this angle x that I have and I divide it by 2. Okay, so if I have an angle that's in the second quadrant of the unit circle, somewhere over here, it's between pi over 2 and pi on my unit circle. If I were to cut it in half, realize that x over 2, that angle cut in half, each of these boundaries also needs to be cut in half. So this becomes pi divided by 2, right? Divided by 2, divided by 2. This divided by 2, pi over 2 cut in half. Well, a half of a half is a fourth, right? So this is pi over 4. So my half angle, x over 2, I can figure out that it's between pi over 4 and pi over 2. Where is that on my unit circle? Well, pi over 4 would be right here, and pi over 2 would be right here. So I'm talking in this green area, right? What quadrant is that in? Or what quadrant is that a part of? Well, that's part of quadrant 1, right? Which means both my sine and my cosine, my x and my y, are positive. Okay, so both of them are positive. So when I do the sine of x over 2 and the cosine of x over 2, both of them are going to be positive fractions. Now, that's important because remember my formulas. My formulas give me the option of positive or negative. So I can use what I know about the unit circle, what I know about my x angle and cutting it in half, figure out what quadrant am I in. That's going to tell me, do I choose positive or negative for my sine half angle and my cosine half angle, all right? So now I can find an exact value for the sine and the cosine of x over 2. I'm going to start with the sine, and I know it's going to be the positive version of the square root of, let's see, sine is 1 minus the cosine, which is negative 12 over 13, all divided by 2. Okay, so let's see if I can take, all right, give myself a little bit more room here. So I just plug the cosine of x into the formula that I already have for the sine of x over 2, because remember, the sine of x over 2 was equal to positive or negative square root of 1 minus the cosine of x over 2, right? We have that right up here somewhere, or right over here somewhere, wherever it is. There it is, right? 1 minus cosine theta, which is x, totally fine, over 2. So I'm using that idea here, and now I'm just going to simplify whatever's under that square root. The first thing that I notice is that I'm subtracting a negative fraction minus a negative, which means I actually need to go positive, positive, right? Positive, positive. So 1 plus 12 over 13 is the first thing I need to do. 1 plus 12 over 13. That's equal to, well, this could, I guess, become 13 over 13, right? So it becomes 25 over 13, right? So this is really the square root of 25 over 13 divided by 2. But what's 25 over 13 divided by 2? Well, that's sort of like timesing by a half, isn't it? So doesn't it then become 25 over 26? Because 25 times 1 is 25, and 13 times 2 is 26. So the sine of x over 2 is equal to this square root of 25 over 26. Okay, and now we could, of course, simplify that radical down if we wanted to. We are allowed to take the square root of the top. Square root of 25 is just 5. The square root of the bottom I don't necessarily know, so I'll leave that as square root of 26. And then I can rationalize that denominator, right? All of these things that we know from previous classes, multiplying by radical 26 by radical 26. So I end up at 5 radical 26 over 26. And that is as simple as I can make it. So this is the sine of x over 2. Okay, so it came from finding the cosine value from my triangle and then plugging that cosine of x value into the sine half angle formula. Okay, now if we do it with the cosine of x over 2, if we want to find that cosine of x over 2 in this particular case, that again is also going to be positive based on what I know from my unit circle, right? Positive, and this is 1 plus the cosine of x over 2. So now in this case, because my cosine value is negative, 1 plus cosine actually ends up being 1 plus a negative 12 over 13 over 2. 1 plus negative is sort of like minus. 1 minus 12 over 13 is actually 1 over 13. When I divide that by 2, I get 1 over 26. That's under a square root. I can square root the top and the bottom, because the square root of 1 is 1 and the square root of 26 just stays that way. And then I can rationalize the denominator and I end up with this. Radical 26 over 26. There's no 5 in front. The 1 could be multiplied in front, but it's not necessary. Okay? So again, we can use these half angle formulas. If we know the cosine value, we can find the value of the sine of half the angle or the cosine of half the angle. Okay? If you have questions about how we might apply these formulas, there is a math notes box, by the way, for you on page probably 303, 304, that goes through the formulas for you. And if you have questions, like I said, please reach out to me. I'd be happy to help, happy to talk you through any example of applying these formulas. If not, that's all I have for you right now, and we will talk to you soon.